So now in this topic beta we will start refraction from spherical surface. Okay, so what we have here, we have this our spherical surface is there. Okay, it has different medium mu2, and here outside we have beta, we have air or any other medium that has a refractive index mu1. Okay, and here our object is there o. Okay, this is our object is there, and distance from this spherical surface here, this is, let's say, u. Okay, now beta here, this is the center of radius of curvature of this surface will be there beta here, radius of curvature, this will be C point here. Okay, so beta here from the ray, now beta what will happen, one ray will go from the object and it will incident at this normal here, and let's say beta here this point is A and it is making incident angle I. Okay, so after the incident beta what will happen, the ray will move towards the normal because it is going from rarer medium to denser medium. So this ray is there, but after the refraction it will go and it will move towards the normal like this. Okay, let's say beta here this angle we are getting, this angle is what, let's say beta, and this angle is what beta, let's say this is R angle. Okay, angle of refraction. Okay, that we are saying. Okay beta, now here let's say if I am putting one perpendicular from here and this point is what beta M. So here our final image will be there beta here, because one ray will go like this here, O to C, it will go without any deviation. So these two ray will meet here and my image will be at I point here like this, my image will be there. So this distance from this image distance from spherical mirror, let's say but I am saying V, and the distance of center of curvature from spherical mirror is what beta, capital R, that is what beta, radius of curvature, and this is red one is what beta, normal line here. Okay, so this is our diagram. This is how the refraction will take place from the spherical surface. Now beta here I will apply Snell's law. First I will apply at point A. So beta how will I apply Snell's law? Refractive index of mu1, angle in the mu1, beta this is the refractive index mu1 here, and here this angle of incident is what beta, sin I is equal to mu2, and angle of refraction is what beta, R here, as you can see this angle of refraction is what beta here, R, so mu2 sin R. Okay, now beta here again beta we will assume that I and R is there beta, they are very small. If I assume that I and R are very small, then beta here what will I write, mu1 I is equal to mu2 R. I can write now beta, when angles are very small I can write sin theta, sin I is approximately equal to I, and sin R approximately equal to R. Okay, now beta here I will do in triangle AOC. Now that this triangle AOC here, in this triangle here I will write one thing beta here. Okay, first let me assume that this angle is alpha and this angle is gamma. Okay, so can I say that beta, this outside angle is what beta, I. In triangle AOC this outside angle is I, this inside angle is what beta, alpha plus gamma. So can I say beta, I is equal to alpha plus gamma, I can say that. And if from this here, this is the one thing I can say. Okay, now triangle, another triangle beta I will take here, ACI. Okay, another triangle is what beta, ACI, triangle ACI. Now beta this triangle ACI is what beta, this one here. Okay, in this triangle A, one angle is what beta, R, another angle is what beta, this beta, and another angle will be this gamma here. So gamma is outside angle and R plus beta is inside angle. So can I write beta here, gamma is equal to nothing but R plus beta, gamma is equal to R plus beta, and from here I can find out R is equal to what beta, gamma minus beta. Now but what I did, I find out I value and R value, that I find out. One thing I find out, understood? Okay, now but another thing I will find out in triangle AMO. But this triangle you are seeing AMO. Now beta in this triangle I will write tan alpha. So what you can say, tan alpha is equal to what beta here, let me write here, in this tan alpha what you can say, perpendicular AM by base, that will be MO. Okay, and this angle will be small, so tan alpha I can write alpha is equal to AM divided by MO. Okay, one point here I can write. Now beta here again, this is in which I am saying triangle AMO. Beta similarly, if in another triangle here, let's say triangle AMI, if I write here tan beta, triangle AMI, you understood, this triangle AM and this is I here. If I write here tan beta, I will write beta AM divided by MI, correct na? Or from here beta will be equal to AM divided by MI. Okay, because angle is small. Similarly beta here I will write triangle AMC. This triangle AMC, tan gamma, what I can write beta AM divided by MC. In triangle AMC, if I write tan gamma, I can write beta AM divided by MC. Again beta angle will be small, so gamma is equal to AM divided by MC. Understood? Angle is small beta, so triangle AMC, this is our A here and this is our M here and this is our C here. In this triangle AMC, tan gamma I can say beta AM divided by AC. Understood na? So gamma is equal to AM divided by AC. Now beta here this was our equation, I got equation 1. Let's say mu1 I is equal to mu2 R. Okay, so in this beta I will write I value. So I value is what beta? Alpha plus gamma is equal to mu2 R. R value is what beta? Gamma minus beta. Now beta here mu I alpha. Did I find out alpha? Alpha is what beta? AM divided by MO. So I will write here alpha AM divided by MO plus gamma. I have find out beta here AM divided by MC. Okay, and mu2 gamma is what beta? Again AM divided by MC minus beta. Beta I find out beta here AM divided by MI. So I will write here beta AM divided by MI. Now beta here what will I, AM to AM will cancel out. This AM here I will take common and it will cancel out here. Mu1 divided by 1 upon MO plus 1 upon MC is equal to mu2 1 upon MC minus 1 upon MI I will get. Okay, now beta here this MO is this one beta, this up and this, let's say this point is P. Can I say that MO is there beta, that is approximately equal to PO? Because here this is very few distance will be there beta here. And can I say similarly beta MC is equal to approximately equal to PC? Or similarly I can say beta MI is equal to approximately equal to PI. So I write here beta here this MO is there beta, that's MO here. So mu1 MO I will write approximately equal to PI. MC I will write approximately equal to PC. Mu2, this is MC PC minus MI is what beta? PI. Now beta here mu1, listen carefully, mu1 1 upon PO, that is what beta? Object distance from the spherical surface. PO is what beta here? Object distance from the spherical surface in this direction. Now beta this direction I will take negative, so I will write here 1 upon minus U plus 1 upon PC. PC is what beta? Center of curvature from spherical surface, that will be plus R is equal to mu2 1 upon PC means plus R minus 1 upon PI. PI is what beta? Image distance from the spherical surface. This image I am getting here PI, image distance, this one V. Okay, so in this direction but I will take positive because that is the incident ray direction. I will write V here. Okay, so what will I get beta here from this? If we solve this, what will I get? Mu1 minus U plus mu1 R is equal to mu2 R minus mu2 V. This I will bring this side beta here and this I will bring this side. So I will write mu2 by V minus mu1 by U is equal to mu2 minus mu1 divided by R. And this formula is very